Hello, day 2, relating graphs to two variables. The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? Let's look at the table, and we have two rows. Each row represents a variable. The first row, the number of uses, represents our variable that is on our x-axis in all three graphs. Amount of sunscreen is represented on the y-axis. Each of those are our variables, number of uses and amount of sunscreen. In each case, the number of uses goes up by 1, okay? So you can't use sunscreen 1.5 times. You either use it once or twice or 3 times or not at all. Okay? Each time you use sunscreen, okay, the amount left in the can goes down. I think that it's safe to say that the amount of sunscreen left in the can depends on the number of times you use it. So how much does it go down each time? Well, it starts out with 0 uses and 5 ounces. Okay, incidentally, that's 0, 5, and we'll talk about what these coordinate pairs mean later. And after 1 use, you have 4.8 ounces. What's the amount of change? 0.2. 0.2 ounces in 1 use. When you use it from the first time to the second time, there is between 4.8 and 4.6, again, a 0.2 difference. And between 4.6 and 4.4, after the second use, you have 4.4 left, so again, it went down by 0.2. Armed with this information, let's answer the following questions. Should the horizontal distance, and that means this distance on the x-axis, between points shown in the correct graph be constant? What we mean by that is between the points, should they move the same amount horizontally? And we'll see which ones they do and which ones they don't. Here, 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 here. Okay, do you think that it should be the same amount? Well, it looks like it changed the same. It changed 1 every time. So yes would be the answer. Yes, the distance between the points that they've moved over horizontally should be constant. Over here, should the vertical distance between the points in the correct graph be constant? Well, let's see what happened. It went from 5 to 4.8, and from 4.8 to 4.6, and so on. The next time, they all changed by the same amount, 0.2. So that stands to reason that there should be the same amount of decrease vertically. And let's look at whether there is or not. Here. Here. Okay. So we would have to say yes. According to the data, approximately how many uses does the can of bug repellent contain? So if we kept on going, how far would we get till we had nothing left in the can? Take a moment and figure that out. Well, if you kept on going and you kept decreasing by 0.2 the whole time, you would come up with a total of 25 uses. That's 25 times 0.2 is going to give us 5.0, and that's the amount of ounces we have. Here's the last question, and this one is going to really test what you think about this. How can we eliminate choice A just by looking? I want you to answer that question, and we will talk about it in Teacher. Okay, turn the page. We are going to talk about how to sketch a graph by reading a situation. This one's about rocketry. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. So this part here, where it asks you what sketch could represent the height of the rocket, this is where you get the information as to what the variables are. Obviously, since we're talking about what happens over time, it rises quickly and then slows, we can assume that time is on our x-axis. Okay, the question always is, well, what's on the y-axis? Well, here's your answer to the question. The graph could represent the height of the rocket during its flight. Okay, so height is on the y-axis. Height goes up here from 0 going up, and time increases going along the x-axis. So let's look at the graph as it describes the situation. The rocket rises quickly and then slows. So it stops rising here and slows to a stop as its fuel burns out. It begins to fall quickly until this point where the parachute opens. Once the parachute opens, it falls less quickly or a lot slower and at a pretty much constant rate until it gets to 0 height, which is the same as the ground. So this is an example of how you would read a problem, model it, label what's happening at each part of the graph. Okay, turn the page. We're going to try one. Suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. What sketch of a graph could represent how your height from the ground might change over time? Label each section. Let's not look at B right now. Go ahead and label your graph and sketch a graph. Give it a try. Pause. Okay, students, you never need to feel badly about your drawing because I draw like this. So if you look at this graph and this is the amount of time increasing and your height off the ground on your swing, you always really have to come down to here. So my graph really should come down to the same point that I started, because this is the starting point. Every time you swing right back down to where you started, but you don't swing up as high every time. And what you notice is you come down as fast as you go up when you're really going. But at the top, you really should slow down a lot more. So this is the point where you reach the top and you're really not going up or down at any fast rate. This is a slowing until you start your descent. And your speed up and your speed down is about the same as you're swinging back and forth. Speed down. Okay? So work on that, and hopefully you'll get to be a better drawer than I am. Okay, the next thing we're going to talk about is having you identify the variables for each of these. Answer the question, what are the variables in each graph? After you do that, label the graph and tell exactly what's going on at each point or portion of the graph. What happens here? What happens at this point? And then what happens for this part of the graph? This is the number of pounds versus how much something cost. Time and the height of grass. I wonder what this is about. So label what's happening here, here, here. So I'd like to see some labels of what you think is happening at each point. Okay? All right, do that and bring that to the teacher station. Also, what are the variables in this graph? Describe what's happening at various points. What's happening here? What's happening all along here? And what does this mean? We'll talk about this in Teacher.